Our first section is section 1.1, where we will discover things about variables and expressions. So to start, we will begin with our vocabulary for this section. A variable is a letter that is used to represent one or more numbers. Expressions consist of numbers, variables, and operations, but do not have an equal sign. If it had an equal sign, that would be an equation, not an expression. An algebraic expression is an expression, so again, it does not have an equal sign, that includes at least one variable. So in order for it to be algebraic, it has to have at least one variable. This is also referred to as variable expressions. So you'll hear these used interchangeably. Algebraic expression and variable expression is exactly the same thing. It does not have an equal sign, but it has at least one variable. In your homework, you're going to see a phrase that says, evaluate an algebraic expression. In order to evaluate an algebraic expression, what you're going to do is substitute a number, and that number will be given to you for each variable, perform whatever operation is present, simplify it if necessary. So again, you're going to plug the number in, which the fancy way to say that is substitute, figure out what it is according to whatever operation is in the problem, and then just simplify it for your final answer. We'll see some examples of that in the following slide. So let's take a look at example number 1. It says evaluate the expression when c equals 4. So when we look at part A, we see 4c. There's an implied multiplication between the 4 and the c. So what we're going to do is take the 4, the c equals 4, take the 4 and substitute it in for the c in our algebraic expression. So it would look like 4 times 4. I've used parentheses here to imply multiplication. Another way to do it would be to take 4 times 4 with a little dot. Another way to look at it would be 4 little x times 4. All three of these ways mean the same thing, and either way that you do it, you will still end up with 16 once you simplify. So 4c when c equals 4 is equivalent to 16. Now let's move on to part B. We have 8 and then a bar and then over c. What that bar means is to divide. So what we have here is 8 divided by c. Once again, we're going to take the c equals 4, take the 4 and substitute it in for the c in our algebraic expression. So it would look like 8 divided by 4. Another way you can look at it as 8 and use the actual division symbol, but either way, you're still going to take 8 divided by 4, and it's going to be equivalent to 2. So no matter how you look at it, you're still going to get 2 as your final answer for 8 divided by c when c equals 4. Moving on to part C, we have 15 plus c. So this one's a little more straightforward. We're still going to take that c equals 4 that we were originally given, take the 4 and substitute it in for the c in our algebraic equation. So it would look like 15 plus 4, and 15 plus 4, when we simplify that, would give us 19. So 15 plus c when c equals 4 is equivalent to 19. Now let's look at example number 2. It says you are ordering a skateboard and a helmet from an online store. The total weight of the two items can be represented by S plus H. So here we're given an algebraic expression where S is the weight of the skateboard and H is the weight of the helmet. Find the total weight if the helmet weighs 1.3 kilograms and the skateboard weighs 5.4 kilograms. So let's start with our algebraic expression. We were given S plus H for algebraic expression, and we're told that the weight of the helmet is 1.3 kilograms. So that means that H is 1.3 and the skateboard weighs 5.4. So that means that S is equal to 5.4. So just like in the previous example, we're going to take the 1.3 and substitute it in for the H, and take the 5.4 and substitute it in for the S. So it would look like 5.4 plus 1.3, so our total weight would be 6.7, and since this is a story problem, we want to make sure that we put a label on our answer. So it'd be 6.7. We were given that the label would be kilograms, so we can just say kg for our label. Next, we're going to look at expressions using exponents. A power is an expression that represents repeated multiplication of the same factor. For example, 81 is a power of 3 because 3 times 3 times 3 times 3 is 81. A power can be written in a form using two numbers called the base and the exponent. The exponent represents the number of times the base is used as a factor, or that many times the base is going to be multiplied by itself. So looking at the example, we have 3 to the 4th, which we learned up here is 81. The big number is the base. The little number is the exponent, so 3 to the 4th would be 3 times 3 times 3 times 3. So again, this is called the power. The expression itself is called a power. Specifically, the big number is the base, the little number is the exponent. The little number tells you how many times you're going to take the base times itself. So if it's 3 to the 4th, again, it'd be 3 times itself 4 times. So it says 4 factors of 3. We'll apply this idea to the following examples. So here's example number 3. It says write the power in words and as a product. So first we have A, which is 1 over 5, so 1/5, and it's raised to the first power. So that would be written as 1/5 to the first power. As a product, that just means to write it as a multiplication problem. So if I'm just supposed to take 1/5 to the first power, that just means 1/5 one time. So this would just be equivalent to 1/5. If you look at part B, we have 3 to the 4th. So in words, that would be written as 3 to the 4th power, and as a product, again, that means to write it as a multiplication problem, that would be 3 times 3 times 3 times 3. So if you can see there, we have 4 3s. For part C, it says p to the 3rd power. A way to write that would be p cubed. Anything raised to the 3rd power can be written as cubed. So p to the 3rd power would be one way to write it, but the more common way is to say p cubed. That would be, as a product, p times p times p, so p 3 times. Moving on to part D, we have 6 to the 2nd power. Another way to write that would be 6 squared. So just like with something that's raised to the 3rd power, we more commonly say that as cubed. When something's raised to the 2nd power, we more commonly say that as squared. So as a product, 6 squared would be 6 times 6, so 6 twice. And now finally, example number 4. It says evaluate the expression. For part A, we have n to the 5th when n equals 3. So what we're going to do is replace the n with a 3. So we're going to take 3 to the 5th power. That's equivalent to 3 times 3 times 3 times 3 times 3. When it says evaluate the expression, that means we actually need to figure out what this is equivalent to, the actual answer, unlike before when we were just supposed to write it as a product. So if this was the previous problem, we would just leave it as this because it just said write it as a product. This time it actually says to evaluate it. So we're going to have to take 3 times 3 times 3 times 3 times 3 to figure out what that actual answer is. So 3 times 3 is 9, times 3 again is 27, times 3 again is 81, and 81 times 3 is 243. So that would be our final answer. Now let's look at part B. It says d squared when d equals 9 over 5. So we're going to take the 9 over 5 and put it in place of the d. So we would take 9 over 5 squared. So what that means is 9 over 5 times 9 over 5. So just remember, when you're multiplying fractions, you just multiply straight across. So 9 times 9 is 81. So our numerator would be 81. And in the denominator, 5 times 5 is 25. So our final answer would be 81 over 25. That's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.